We are looking at chapter number 15, which is the probability. So in everyday life, there are various statements we will come across. That is, it will probably rain today. I doubt that he will pass the test. So probably doubt. Most probably Kavita will stand first in the annual examination. Chances are high that the prices of diesel will go up. And there are 50-50 chance of India winning a toss in today's match. So this probably, doubt, most probably, chance, all these are words of prime importance because we are uncertain. These words represent uncertainty. That means in the first, if we see the statement, the probably rain means it may rain, it may not rain. Similar is the prediction with others also. So the uncertainty of probably, this can be measured numerically by means of probability in various cases. So we'll learn about this probability, and probability is, see, it's very is extensively used in the physical sciences, the commerce, the biological sciences, the medical sciences, weather forecasting, etc. So probability, this can be taken as an experimental approach. So when we do experiments, we can find out certain way how to find out the probability. So the concept of probability developed in a very strange manner. In 1654, a gambler, Chevalier de Mer, approached a well-known 17th century French philosopher and mathematician, Mr. Blaise Pascal, regarding certain die problem. So Pascal became interested in these problems and he studied them, and he discussed this with another French mathematician, de Fermat. Both Pascal and Fermat solved the problem independently, and this work was the actual beginning of probability theory. So the first book on the subject was written by Italian mathematician J. Cardano, and the title of the book was Book on Games of Chance, published in 1663. And there are other contributions also by Bernoulli, by Laplace, by Marco, by Kolmogorov, and we'll see about mostly the coin and a dice. So coin, a fair coin, has a head or a tail on its face. A die has 1 to 6 dots in its face because there are six faces of a cube. So there are 6 faces, and whatever comes when you throw it or toss it, this will be termed as outcome. So we will try to measure the chance of occurrence of a particular outcome in an experiment. First, let us take say any coin, toss it 10 times, and note how many times does head or tail come up, and record your observation here. The number of times the coin has been tossed is 10. Number of times, say 6 times head has come, 4 times the tail has come. This you can write, right? So you just write down the values. That is, first of all, in both the cases, we have to write total number of times the coin was tossed in both of them. Say 10 times, right? Now 6 times head has come up, so 6. Say 4 times the tail has come up. So this is how we write. Then do it for 20 times. Then go for as many as times you want. So if you approach, say 100 or 500 or say 1000 times do you toss a coin, you see that the head and tail probability, which is the number of times the head has come divided by total number of times the coin was tossed, and the number of times the tail has come divided by total number of times the coin was tossed, you'll see they will approach 0.5. They will approach 0.5. So now you can just do some other activity, and you see when we have a group, a number of heads has come 3, number of tails has come 12, and if you divide this, means try to find out the cumulative probability of head. So this is 3 by 12 plus 3, that is 15. And cumulative number of tails will be, so 12 is 12, so 12 by 15, total is 15. And now see, when you do it next time, the other group does next time. Now 7 plus 3 is the total number of heads, and how many times it has been done? So 15 plus 15, 30. So 10 by 30. In the similar case, this is 8, but previously it was 12, so 12 plus 8 cumulative we are adding, and cumulative times 15, 15, that is 30. 20 by 30. Again we add 7 plus 7 plus 3, that is 7 plus 7 plus 3, and then we divide it by 17, that is 17, divided by 15 plus 15 plus 15, that is 45. Again for the tails also will do the same thing. And we see when we go on and on and on, the number becomes nearer to 0.5. If you do it for the die also, die, as I said, is a cube having 6 faces. The faces will contain number from 1 to 6, or they are number marked 1 to 6. So 1 to 6 can come up. So you can record the observation like this. You can do the you can throw the die and you see how many number of times this 1 has come, 2 has come, 3 has come, and you can just go on and on. Like number of time 1 has come, total number of times the die is thrown, 2 turn up, 3 turn up, 6 turn up, like this. So if you throw, say, dice 40 times or 100 times or number of times, as many as times you want, and if you go higher and higher, you say that the probability of getting 1 or 2 or 3 or 4 or 5 or 6 becomes 1 by 6. So this is also a cumulative version. You can just add how many times 1 has been thrown, then you can accumulate it, the next time. So totally the cumulative number of times the 1 has turned up divided by the total number of times the die has been thrown is going to be near 1 by 6. And this is true for not only 1, this is true for 2, 3, 4, 5, 6, like this. Okay? And we can do some other activities just to indicate that the probability is an experimental fact. If you go on and on and increasing the number of observation, you will see it will come nearer to what it should be. That is, if head and tail are the possibility, that is, we have two possibilities. Head possibility is 1, this becomes 0.5. This is the probability of getting head, and the probability of getting tail is similarly 1 by 2, which is 0.5. So probability of getting head or tail is 0.5. So what is a trial? Tossing a coin is a trial, throwing a die is a trial, and a trial is an action which will result in one or various or several outcomes. The possible outcome of, say, tossing a coin is head and tail. In the throwing of dice, the possible outcomes are 1 to 6. So the event getting a head or a tail in an event is this outcome is in an event, right? Getting a tail is also an event with outcome as tail. So you are talking about event. So event is, you can say, an event for an experiment is the collection of some outcomes of the experiment. So empirical or experimental probability, when we have some background, we have done certain experiments, we have done some certain trials. So the experimental or empirical probability, let us take n be the total number of trials, that is this is n. The empirical probability, that is p bracket e, this is empirical probability of event e happening, is given by number of trials in which that event happened. Please understand, not number of trials, but in number of trials. Say you did trials for 10 times and that particular event occur only 2 times, so it will be 2 and this is 10. So total the number of trials in which the event happened, you have to put it here, and the total number of trials you have to put it here, right? So this is the probability, which is the number of times that event has occurred and that the total number of trials which has been performed. We'll take some example, right? And then we'll try to find out what is the exact probability. So for example, we have a coin which is tossed 1000 times. So the number of trials is 1000 times, and these are the frequencies: head 45, 455. So this is the probability of head. Tail 545. This is the number of number of trials in which the event occurred is 545, total number of trials are 1000. So this is the probability of head, this is the probability of tail. So total probability of E, total number of heads by total number of trials, 455 by 1000, that is 0.455, and the probability of getting the event of getting a tail is number of tail by total number of tails. This is 545 by 1000, that is 0.545. If you add these two, you will get 1. So probability of getting head and probability of getting tail, they will add up to 1, and this is very important because E and F are the only two possible outcomes of each trial. So when you add them, it has to come 1. The probability varies from 0, that is in all the trial, none of the trial has that event occurring, that is that event never occurred in that trials, which is 0, and every time you did the trial or at that trial every trial that event has come up, so the probability will be 1. So probability varies from 0 to 1. You will find the values always between 0 to 1. So 2 coins are tossed simultaneously 500 times and we get 2 heads 105 times, 1 head 275 times, no head 120 times. Find the probability of occurrence of each of these events. So this is 105 by 500. This is the probability of first event. 275 by 500, second event. 120 by 500, three event. E1, E2, E3. And if you add these two, P1, PE1, PE2, PE3, that will be going to be 1 because E1, E2, E3, they cover all the outcomes possible of a trial here in this example. A die is thrown 1000 times with the frequency for the outcome 1, 2, 3, 4, 5, 6 in this table. So the outcome is 1 to 6 and the frequency is this. So we have to find the probability of getting each outcome. So how to get this? We know that the probability of outcome of 1 is the frequency divided by the total number of trials. So 179 divided by 1000. Similarly, for this second one, getting 2 is 150 by 1000, getting 3 is 157 by 1000, 149 by 1000 for 4, 175 by 1000 for 5, 194 by 1000 for 6. So this is all you get. P6 190 by 1000, just add all of these, you get 1. So the probability of each event will lie between 0 to 1. If you are getting below 0 or above 1, that means there is some error we need to rectify. Then sum of all the probabilities of all the possible events which are being said for an experiment, they must add up to 1. E1 to E6 cover all the possible outcomes of a trial. Now we have an example on one page of telephone directory. There were 200 telephone numbers. The frequency distribution of their unit place digit, for example this, where unit place is 3 is given like this. Getting a 0 here is 22, 1, 26 like this. So without looking the page, the pencil is placed on one of these number and the number is chosen at random. What is the probability that the digit in its unit place is 6? So this is 6. We need to find out for 6. Let us go to 6. This is 14 by 200. So we have 14. The frequency of 6 is 14 in the table. The total number of selected telephone numbers are 200 as given in the question. So 14 by 200, that is the event, or you can say the favorable number of times that the trial has got an event, and this is the total number of trials being done. 14 by 200, that is 0.07. This comes between 0 to 1. So this is correct. The record of a weather station shows that out of the past 250 consecutive days, its weather forecast were correct 175 times. What is the probability that on a given day it was correct? So the total number of days for which the record is available is 250, right? Its weather forecast were correct 175 times. So the forecast was correct on a given day, that is 175 by 250, that is 0.7. Now the total number you can also find out in similar way. You don't have to go to the second one. I'll tell you how. You have to find out what is the probability that it was not correct on a given day. So we have correct, and this P not correct, NC, let me write, P not correct is simply 1 minus this one, P correct, right? So we have this answer as 0.7. So 1 minus 0.7 is, this is the correct one, and 1 minus 0.7 is for non-correct. So 0.3 is the not correct forecast. But we'll do in some other way also. See, 250 is total, correct is 175, subtract them, you get 75. This is the incorrect one. So 75 by 250 is the probability that the forecast was not correct on a given day. If you add them, 0.7, 0.3, you'll get 1. A tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. This table shows the result of 1000 cases. So the distance which is less than 4000, 4000 to 9000 like this, these are the frequency. If you buy a tire of this company, what is the probability that it will need to be replaced before it has covered 4000? So this is 20 by the number, which is I'll tell you 20 by this 1000 will be the answer of this. I'll tell you one by one. Let us get some rough idea now. It will last more than 9000. So 9000, more than 9000 means this. So 325 plus 445 divided by 1000. Then it will need to be replaced after it has covered somewhere between 4000 and 14000, like this. So 210 plus 325 divided by 1000 is the answer. So total number of trials is 1000. The frequency of tire that needs to be replaced before it covers 4000 km, as you just saw in the table, is 20. 20 by 1000 is 0.02. Now the frequency of tire, second one, that it will last more than 9000 is 325 plus 445, and the frequency of a tire that requires replacement between 4000 and 14000 is 210 plus 325. That means we are talking about 9000 and 4000, and we are talking about 4000 and between 14000, right? So when you add this, you get, first one, let us take 770. So 770 by 1000 is 0.77, and 535 by 1000 is 0.525. The percentage of mark obtained by a student in the monthly unit test is given like this. Based on this data, find the probability that the student gets more than 70% mark in a unit test. So 70%, more than 70%. That is, we have to choose scoring 70, this 1, 2, 3, 4. So the number of unit tests in which he scored more than 70% marks is, you see here, total number of unit tests is 5, and total unit test where he scored more than 70 is 1, 2 and 3, because 69 and 68 are below 70. So 71, 73, 74, so there are 3 possibilities or 3 event or trial where the event has occurred or can occur. And what are the number of tests? 4 or 5 total. So 3 by 5 is the probability, 0.6. An insurance company selected 2000 drivers at random without any preference of one driver over another in a particular city to find a relationship between age and accidents. The data obtained are given like this. So we have age 18 to 29, and the accidents in 1 year 0, 1, 2, 3 over 3 are like this, right? So 18 to 29, the accidents in 1 year 2, that the number is 110. Above 50, these are the numbers over 3. So they above 50 over 3, there are only 9 accidents which are being done. So find the probabilities of following events for a driver chosen at random from the city. Being 18 to 29 years of age and having exactly 3 years in 1 year. So 18 to 29 and exactly 3. So these are 61, right? 61 divided by 2000. So this becomes 61 divided by 2000. This is the probability. Being 30 to 50 years of age and having 1 or more accident in a year. 30 to 50 and having more than 1 or more accident, 1 or more. So we'll take this. All this we have to add. 125 plus 60 plus 22 plus 18. So we have to add 125, 60, 22, 18 we have to add, because this is over, means 1 or more. So we have to get 225. This is the number which is the favorable cases, or you can say the event occurred in these trials, and these are the number of trials, or these are the number of the cases total, which is 0.113. Now the third one is having no accident in 1 year. So no accident in 1 year, 0. That means 0 accident. So all these have to be taken care. So 440, 505, 360 we have to add. This is 1305 by 2000. This is 0.653. Consider the frequency table. We'll see the frequency table and just assume that we have already seen that frequency table. I'll just explain you, which gives a weight of 38 students of a class. Find the probability that the weight of a student in the class lie in the interval 46 to 50. So the total number of students 38, and the number of students with weight in the interval 46 to 50, if we assume it to be 3, so 3 by 38 is the answer, that is 0.079. Given two events in this context, one having probability 0, another having probability 1. So the simple answer would be an event that the student weighs 30 kg. This is, since no student has this weight, the probability of occurrence of this event will be 0. And the probability of student weighing more than 30 kg, because there is no student which is having, there are all students which are having 30 kg and more. So 38 by 38, this will be 1. 50 seeds were selected at random from each of 5 bags of seeds and were kept under standardized condition favorable to germination. Now after 20 days, the number of seeds which had germinated in each collection were counted and recorded like this in the table. So we have bag 1, 2, 3 to 5, and number of seeds which are being germinated are given like this. So let us see what question are being asked. First is, what is the probability of germination of more than 40 seeds in a bag? So more than 40 seeds in a bag, more than 40, so 48, 42 and 41. This we are going to take because we are being talked about more than 50. So we have 3 of them, so 3 divided by 5, total of 5. 49 seeds in a bag, 49 seeds in a bag. Let us see 49 seeds in a bag. So we have no number as 49, so 0 by 5, 0. And then more than 35 seeds in a bag. All of them are having more than 35, so just add all of them, and these are 5 basically. You don't have to add, they all are 5 because all are more than this, divided by 5, that is 1. So this is the probability of getting 0 and 1. So let us summarize what we have seen. An event for an experiment is the collection of some outcomes of the experiment. The empirical probability PE, this probability of event E is the event, P is the probability of event E, is given by PE, which is the number of trials in which E has happened and total number of trials divided by total number of trials. So the probability of event lies always between 1 and 0, 0 and 1 are inclusive. So this is all about this chapter. Thank you so much and take care of yourself.